Hello students, let us learn today one concept from the topic circle. The concept is theorem of angle between tangent and secant. So first of all, let us have the statement of the theorem. If an angle has its vertex on the circle, its one side touches the circle and the other intersect the circle in one more point, then the measure of the angle is half of the measure of its intercepted arc. So let us start to understand this theorem by using the diagram. Suppose if we have a circle where angle ABC is given. Now side BC of angle ABC touches the circle at point B, that is B is point of contact, and the other side of the angle is AB, which intersects the circle at point A. In this diagram, the second side of angle ABC passes through the center of the circle. So this is the first condition that we may get. We have another possibility that if there is a circle given and there is an angle ABC, the first side touches the circle at point B, and this time the second side of an angle ABC intersects the circle at point A, which makes an acute angle. So this possibility also can be there, and we have another possibility that the angle which is an obtuse angle. So here in the third diagram, the second side of angle ABC intersects the circle at point A, which makes an obtuse angle. Now for all these three diagrams, we are given that for angle ABC, the vertex B of angle ABC, which lies on the circle. Now for all these diagrams, side BC touches the circle at point B and side BA intersects the circle at point A. In this case, arc ADB is intercepted by angle ABC. So as we can see, for all these diagrams, arc ADB is intercepted by angle ABC, and for third diagram also, arc ADB is intercepted by angle ABC. Now if this is the case, then measure of angle ABC must be half of the intercepted arc, as the statement suggests that. Then the measure of angle is half of its intercepted arc. That means measure of angle ABC is equal to half of measure of arc ADB. So this theorem is known as theorem of angle between tangent and secant, as one side of angle touches the circle, that's why it is a tangent, and other side intersects the circle, that's why it is a secant. So the theorem is called as the theorem of angle between tangent and secant. Now we can see this theorem using another angle. That's why we have alternate statement of this theorem. Suppose this circle is given where angle ABC, for this angle side BC touches the circle at point B and AB intersects the circle at point A. In this case, by using the previous theorem, we can write measure of angle ABC must be half of the intercepted arc, that is half of measure of arc ADB. So this can be written by using the previous theorem. Now if you consider angle ATB, where T is any other point which is taken on the circle, and we have joined here AT and TB. For this angle ATB, arc ADB is also intercepted by the same angle, that is arc ADB is intercepted by angle ATB. Now by inside angle theorem, we have measure of angle ATB must be half of measure of arc ADB. So that can be written as angle ATB is equal to half of measure of arc ADB. So from these two we can conclude that measure of angle ABC is half of arc ADB, and also measure of angle ATB is half of arc ADB. That's why measure of angle ABC is equal to measure of angle ATB. So this is the alternate statement of the above theorem, that an angle between a tangent of a circle and a chord drawn from the point of contact is congruent to angle inscribed in the arc opposite to the arc intercepted by that angle. Now let us study another theorem, tangent secant segments theorem. Let us have its statement. For this diagram, if point E is in the exterior of a circle, the secant through point E intersects the circle at point A and B respectively, and a tangent which is drawn through point E which touches the circle at point T. That's given. So if it is the case, then we have EA into EB, that is equal to ET square. As we can see in the diagram, EA into EB, that must be equal to ET square. So we have to prove this. For that we have to do one construction. We have to draw segment AT and segment TB. Now by doing this construction, we have got two triangles, triangle EAT and triangle ETB. Now for these two triangles, we have angle AET which is congruent to angle TEB, because this is the common angle for both of these two triangles. That's why these two angles are congruent, because of common angle. Second component is angle ETA. This one is congruent to angle EBT, and this is because a tangent secant theorem. Now for these two triangles, two angles of first triangle are congruent to two corresponding angles of the second one. That's why these two triangles must be similar by A test. So triangle EAT is similar to triangle ETB. And we know that if two triangles are similar, then their corresponding sides are in proportion. So if we take side ET, its corresponding side will be EB. So ET divided by EB is equal to EA, its corresponding side is ET, is EA divided by ET. If we cross multiply, we get ET into ET, that's ET square, is equal to EA into EB. So we get EA into EB is equal to ET square. That is what we wanted to prove. So this theorem is known as tangent secant segments theorem.